Hello, welcome to the video abstract presentation on our work, Comparison of Autonomous Orbit Determination for Satellite Pairs in Lunar Halo and distant retrograde orbits. My name is Zhao Gao, a PhD candidate from Nanjing University, and my supervisor is Professor Xiyun Hao. The background of our work is satellite navigation around the Moon, and traditionally the tracking of the lunar satellites is based on the ground stations, and there are some shortcomings of this method. First, the far side of the Moon cannot be covered, and also the tracking is not continuous. And with more and more lunar missions in the near future, the tracking burden of the ground stations is very heavy. Another option is to use the GNSS system around the Earth, but only side lobes can be received by the lunar satellites, and signal is very weak in the vicinity of the Moon. And also the geometry is not good because the observation is restricted to the Earth-Moon line, and this will produce poor GDOP. So based on this background, the Liaison Strategy was proposed by Hale using satellite tracking measurements to autonomously determine their orbits. And the original idea is to use the halo orbits, and Liu et al. Proposed to use the more stable DROs. And our contribution is to combine the halo orbits and the DROs together to build such a navigation constellation. We are doing this in view of 2 points. The first is about their favorable stability, especially for NRHOs and the DROs. The second is about their geometry. The NRHOs are almost perpendicular to DROs, so they will form a good position geometry. And it should be noted that in this paper, we are focusing on satellite pairs. That is to say, we have only 2 satellites in our constellations. And one contribution of our paper is to make a systematic analysis on the autonomous orbit determination performance of different satellite pairs in CRTBP model. And the second contribution is to make a simulation in real force model to verify the actual feasibility and performance. And there are 3 kinds of constellations in this paper: the halo+halo type, the DRO+DRO type, and the halo+DRO type. And the first type consists of 2 kinds of configurations. So totally we have 4 kinds of configurations of satellite pairs. Another contribution of our paper is to propose the DAGDOP factor, which is similar to the well-known GDOP factor, but it is different in the sense of incorporating the geometry and the dynamics. And this factor can be easily extended to the case of multiple satellites and the other types of observations. So based on this factor, we find that the hybrid halo+DRO type outperforms the other types. So finally, the feasibility of the hybrid halo+DRO type is verified in a real force model, incorporating various perturbative forces, the realistic dual one-way ranging model, the different errors including the clock errors, the dynamical model errors, and so on. The Monte Carlo analysis shows that the position error is at a level of 200 meters, and the clock synchronization error is at a level of 30 nanoseconds. So that's all for our video abstract presentation. If you are interested in our work, please check out the paper in Navigation Journal. If you have any questions, please feel free to ask us. Thank you. That's all.